Nearly a third of the AI code fixes that officially pass the industry's big coding test never delete the code they were supposed to remove. They keep it and build a detour around it. And when researchers added a check that fails if the old code is still sitting in the file, the top model's success rate fell from about 63% to about 42%.
No, I don't believe that. If the code passes its tests, the fix is finished. That's what tests are for, isn't it? So you've got the rest of this to convince me.
And I want you holding exactly that, because it's how the entire industry grades these tools right now. Green tests, good fix. So picture hiring someone to knock out the wall between your kitchen and your living room. They leave the wall standing and frame a new hallway around it. The inspector walks through, checks that you can get from the kitchen to the couch, and signs off. You can, he does. 2 years later, everyone who touches that house is asking what that wall is doing there and whether anything depends on it. That's what this paper measured, in code, in the tools now writing a growing share of the apps on your phone. There's a real repair in here where the model kept the exact line a human deleted and tucked it into an otherwise branch. There's a whole set of jobs where deleting was the entire task. And there's one plain instruction you'd swear would fix all of this.
Go on.
Okay, so first, here's the boring fact that makes the whole thing possible. A test can check that something now works, but it has no way of saying, and the old line had better be gone. Nobody writes that, because normally, nobody needs to. So a fix that leaves the old logic running and adds a new path around it satisfies every single check the grader knows how to make.
Right, but framing around the wall is sometimes the correct build, you know? If the bug's gone and nothing else broke, who cares that a few old lines are still in there? Leftover code isn't a crime.
That's a fair case, and the authors say it out loud too. But watch which wall gets left standing. In one real bug, the developer's fix swapped a single line for a better one. The model kept the old line, wrapped a condition above it, and let the old line stay the default for every other input. Both versions passed the same tests. Both were recorded as solved. One retired the line, and the other built a bypass and left it live.
And it just couldn't find the line?
No, and that's the part that surprised me. They checked in 3 nested steps: write file, write function, write line. The models edit the write file more than 9 times out of 10. They cut the exact line less than half the time.
Huh.
So the researchers changed the grader instead of the model. They wrote checks that read the source file and fail if that targeted chunk of code is still present. And they confirmed those checks fail before the human fix and pass after it. Same tasks, same patches, one stricter question. And separately, they tried the obvious thing. They simply told the models, remove it completely, no guards, no fallbacks. Hold on to that instruction because I'm coming back to what it did.
Fine. Point blank then, out of the patches the old tests had already waved through, how many were still keeping the code?
A third. A third of the accepted fixes still had the developer's deleted code sitting in the file. And across those tasks, 4 current frontier models went from about 63% solved to about 42%. Every one of them dropped by roughly 20 points.
So the score everyone quotes was measuring green tests, not a good fix.
That's the swap. And here's what that plain instruction did. Telling the models, delete it completely, no workarounds, moved the results by essentially nothing. Pointing at the right region barely helped. Only handing over the exact lines to remove moved every model. And then they started deleting too much. So it's not that these models refuse to delete. They don't know where a deletion ends. Your old picture was an inspector confirming the doorway works. The real picture is an inspector who was never able to ask whether the wall came down.
Here's what this still can't tell you, though. It can't tell you whether a human reviewer would have rejected those fixes. Sometimes framing around the wall is a legitimate build. This measures a habit, not a verdict on every patch.
Fair, and the authors agree. So let me put it on you. If an AI wrote a piece of the software your bank runs on, Would you want the leftover code checked? Or is working good enough?
And if that question bugs you, subscribe. There's a new paper on this channel every day, and most of them ruin an assumption you didn't know you had.
Watch the next coding leaderboard. The moment one of them starts scoring what got taken out, we'll find out how much of that 63% was ever real.